Hi, I'm Gabriel Payne, a student in Miss Palmer's grade 11 chemistry class. Today I'll be giving you a little bit of insight into what is known as Charles's Law. From the beginning of the 17th century to the end of the 18th century, scientists made great progress in better formulating the relationship between gas and both its volume and pressure. Maybe one of the most prominent theories that emerged during this time period is Charles's Law. Charles's law states that the volume of a fixed amount of gas at a constant pressure is directly proportional to the Kelvin temperature of that gas. By this, Jacques Charles meant that as the temperature of the gas rises, so does its volume, and vice versa. In creating a visual representation to exemplify how this process might play out in real life, it is only right that we use a balloon, as Charles was also a balloonist in his free time. If we were to take a balloon, which acts as a container for helium gas, and increase the temperature of the environment which that balloon is in doing so we will also be increasing the volume of the balloon itself. This theory can also be directly applied in order to solve for missing variables. This is done through the equation V1 over T1 equals V2 over T2. Let's take this question for example. A gas at 89 degrees Celsius occupies a volume of 0.67 liters. At what temperature will the volume increase to 112 liters? So to answer this problem, we first need to plug in our givens. We know that our first volume is 0.67 liters and our second is 112 liters. We also know that our first temperature that is given to us is 362 Kelvin, but we don't know our second temperature. So using algebra, we can cross multiply. We take 362 and multiply it by 112. And we know that that is equal to our second temperature multiplied by 0.67. So now we take 4,054. Oops, I put the 4. Let me make that. Divided by 0.67. And we know that our final answer is 605 Kelvin. Thanks for watching my presentation. If you have any more questions, please email me at the email address below.